Very good evening guys and a warm welcome to Vedantu JEE English channel. What's up? How are you all? Hi Satvik, how are you? Hello Kishant, how are you? What's up? What's up? Very good evening. Quickly go and call up your friends and I think we should begin. Let me just bring my remote here. Yes, hi Hari Prasad, hi Telugu, how are you? Hi, Telugu gamer, so sorry. Yeah. Oh, thank you so much, thank you so much. Alright, so I think we should not waste time because let's face it, 24th is when your JEE exam starts. I think we should start, we should get set go. P-Block mind back. Yes, Danik Reddy, thank you so much for reminding me again. You know what happened, I was not coming to the office for few days and that's why I missed out on it. Today I have come. I have already taken it from the office desktop to my email ID. I will be sending it to you today. Pakka promise. Don't worry about it. Okay. I will pakka be sending it to you. Don't worry about it. Yes. Hello Sachet. Hi everybody. Very good evening and a warm welcome to Vedantu JEE English channel. This is me, your Master Teacher Nabamita Mam, and today we are going to start with coordination compound problem solving. There are a lot of problems. Yes. What about Shiman sir? He's upstairs. He's in Bangalore. He's taking yes. The countdown is start. So let's not waste time guys. Let's start with it. Okay. Let's start with it. Chalo. Let's begin. Now that you are all here, don't forget to like, share and subscribe. If you're liking this session, please do not forget to like, hit the like button also. Yeah. You like the session, hit the like button. Okay. Chalo. Moving on everybody. This is my introduction. Let's forget about that. Let's begin with our first question. The first question is the sum of oxidation state, that is magnitude. Okay. Just the magnitude. No, we are not going to count the negative sign or the positive sign, okay? And coordination number of cobalt in NaCO BPyCl4. BPy is what? Bipyridine. Yes, bipyridine. So you have to find the what? Find the oxidation state of cobalt. Come on, oxidation state of cobalt. Can you find it out? Let's do it. Come on. Can we do it? 3. Are you telling me about the oxidation state of cobalt? Yes, the oxidation state of cobalt is going to be 3. No doubt about it. Cool. So BPy, bipyridine, this is what? It's neutral, right? Answer is 9. Very good. Yes, the answer is going to be 9. Yes, the oxidation state of cobalt will be +3. And the coordination number of cobalt, as we can see, bipyridine, it is what? Bidentate, right? So there are 2 ways that it can hold. So that means 2 here, okay, 2 here plus 4 chlorine, that means 6, right? So 6, bipyridine is bidentate, right? Bipyridine is bidentate, so 6 plus 3 will be equal to 9. Very good, well done everybody, well done. Chalo, moving on to the next question. Let's do it fast, okay? Let's not waste time because I want you all to study more by yourself. Next, the difference between spin on only magnetic moment value of COH2O6Cl2 and CrH2O6Cl3 is. Let's find it out. Okay. What is going to be the oxidation state of cobalt and what is going to be the oxidation state of chromium? Figure it out. Figure it out, or do you want me to do it? Chalo, let's do it. Cobalt is what? 4s2 3d7, isn't it? 4s2 3d7, right everybody? Yes, 3d7, and chromium is 4s1 3d5. Correct? Right everybody? Now, find the oxidation state. Find the oxidation state. Hello Donalu, hello Satyam, how are you everybody? Find the oxidation state of cobalt and chromium. Come on. Where is Shimon? Shimon sir is here only, Baba. He is in Vedantu. He's taking more classes on Master. Maybe that's why you are not seeing him. But he will take it. Don't worry, okay? He will take classes. Don't worry about it. Acha. Cobalt will be in +2 oxidation state, correct? Do we know how to calculate oxidation state? Do we know how to calculate? Yes or no? How many of you know how to calculate oxidation state, everybody? Do we know how to calculate oxidation state? EMCET class bacha after 24th, yeah? JEE is right here, right now. So we have to focus more on JEE, yeah? Yes, and CR is +3 oxidation state. I really hope that you know the oxidation, how to calculate oxidation state. So that means here if cobalt is +2, that means it is 3d7. That means it is 3d7 here, okay? And H2O is a weak field ligand. Am I clear? H2O is a weak field ligand. Who is Abhina? You do not know. You do not know. Amulya, you do not know how to calculate oxidation state. Really? My goodness. How many of you do not know how to calculate oxidation state? Let's see how many of you do not know how to calculate oxidation state. Tell me. Come on. How many of you do not know? Can I see? If you know, then thumbs up. If you do not know, then give me a thumbs down. Give me a thumbs down if you do not know how to calculate oxidation state. Give me a thumbs down if you do not know oxidation state. I don't know. I know. Shiva Gaming. Okay, come on, guys. Faster. Primary and secondary valence. Okay. Okay. There are a lot of people. Chalo, let's do it. See for this, okay? See, let me show you. What is this thing? Na, okay? CO, cobalt, okay? You have BPY and then Cl4. So what we're going to do is we have to find the oxidation state of the metal. This is the central metal atom. Am I right, everyone? This is the central metal atom. So for this, what we are going to do is we are going to denote it as X because we have to find the oxidation state of cobalt. Alright. Now somebody asked me, ma'am, what is primary and secondary valence? Beta, this, the counter ion, the one that can dissociate when you put it in an aqueous solution, that's called as primary valence, and whatever is inside the coordination entity, this is your secondary valence, okay? Alright. Now, X, BPY, this is a neutral ligand. That means it does not have any charge, okay? This is a neutral ligand. Bipyridine is a neutral ligand. But chlorine, what do we see? Cl minus. It has -1 charge. Okay. This has -1 charge. So -1 into 4 will be how much? -4. Am I right? -4. Correct. Now -4 and Na. Na, what do we see? Na is always a plus, right? So -4 plus 1. And all of these, the whole of this, we will equate it to 0. Okay, alright. Now, what will happen is X is equal to -4 will go this side, plus 1 will go that side. So, that means it will be +3. This is how you find out the oxidation state. Got it? This is how you find out the oxidation state. Got it? Very good, Arun. Let's focus here, okay? You can, you definitely can. Yes, it is definitely. I look so bright today. I think it's because of the light in the studio. Anyway, chalo, moving on. Now, can you find the oxidation state for this? H2O is also what? H2O is also neutral ligand, okay? H2O is also a neutral ligand. So, can you find the oxidation state now? Okay? Find the oxidation state now. You will see that CO is +2, cobalt is +2, chromium is at +3, okay? So, if it is 3d7, that means I can draw it like this. See? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6 and 7. How many unpaired electrons? N is equal to 3. Unpaired electrons are 3, right? 1, 2, 3. Okay. What is the formula to find magnetic spin? It is mu is equal to N plus, what is it? N plus 2 root over, isn't it? So that means 3 into 3 plus 2 is 15. This is equal to root over 15. Yes. Now root over 15, how can we figure it out fast? Root over 16 will be 4. So root over 15 will be equal to somewhat 3.9. Am I right? Am I right? Yes. Am I right? Absolutely. Now for chromium, let's see, it's +3. That means it is 3d3. 3D3. Again H2O is a weak field ligand. That means no pairing. 1, 2, 3, 4 and 5, right? So 1, 2, 3. Again 3 unpaired electrons. It will again be same thing, 3.9. So what will be the difference? The difference will be 0. The answer will be 0. 0 is the answer. Got it? Clear? Yes, Harini, long time. How are you? What is meant by T2G and EG? We will talk about it. Mohan Rao, don't worry. I have some questions. We will do it. Don't worry. Okay? Moving on. So this is the solution. The solution is also written here. You can find it out. But anyway, I am explaining it to you. So don't worry. Chalo. Which one of the following complexes will consume more equivalence of aqueous solution of AgNO3? So that means what is AgNO3 will be able to react with something and maybe form a compound. So let's see it. If it is Cl, Cl, Cl is everywhere. That means it is supposed to form AgCl. It is supposed to form AgCl. Now in which one of these most amount of AgCl will be formed? Most amount of AgCl. Even without removing your pen from the question paper, you can answer this. The answer is option C. You know why? Cl3. See, this is primary valence. Primary valency is 3. 3 of chlorine can dissociate from this, but rest see 2 only can dissociate. This is not going, this is going to be less. But here Cl is inside the coordination inside the coordination sphere. Here also Cl is inside the coordination sphere. That means that they are not going to, you are not going to see the presence of chlorine in these cases, right? But here Cl3, 3 chlorine will be able to react with AgNO3 and form AgCl. So option C is the correct answer. Making sense? Making sense, everybody? Are we getting it? Clear hai? Clear hai? Give me some la 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 in the chat box if you all are understanding. Very good. Very good. Give me some la 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 if you are understanding. Chalo, next question. Next question. Oh, thank you. Thank you so much. Acha, the correct combination is, the correct combination. You have NiCl4, NiCN and you have NiCO4. Shall we find it out? Shall we find it out, everybody? Okay, let's do it. So you have NiCl4, 2 minus, NiCl4, 2 minus. So that means it will be X minus 4. Cl has minus 1 charge. I am finding the oxidation state also. Okay? Take a look at it. Dharini, I am so sorry, sweetheart. I am not taking organic chemistry. I am taking inorganic chemistry. So I will have to focus here. Wasim sir is taking care of organic chemistry. Maybe you can follow his classes. Yeah, maybe you can follow his classes. Please take a look at his classes. Chalo. X is equal to minus 4. And then here what do you have? You have 2. Minus 2. So that means X is equal to plus 2. What is the nickel electronic configuration? What is the electronic configuration of nickel? Nickel, copper, zinc. So 3D10, 3D9, 3D8. 3D8, right? 3D8. It should be 4s2, 3D8. 4s2, 3D8. That is the correct configuration. However, since it is already in plus 2 oxidation state, can I just write 3D8? I can write 3D8. I can write 3D8. Correct? If I write 3D8, that means my orbital should look kind of like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons, right? 2 unpaired electrons, am I right? Yes. So if there are 2 unpaired electrons and we know that Cl is a weak field ligand, will there be pairing? There will not be any pairing. There will not be any pairing. If there are no pairing, that means the orbitals that are empty for Cl is S and P3. 1, 2, 3. sp3. So if it is sp3 hybridization, that means what is the shape? The shape is tetrahedral, everybody. Yes, it will be tetrahedral shape, correct? Tetrahedral shape. So tetrahedral shape and there are 2 unpaired electrons, that means it is paramagnetic. Yes, that means it is paramagnetic. So let's see, NiCl is paramagnetic. Square planar, no, NiCl is paramagnetic, this one. Option C is the correct answer, right? Option C is the correct answer, right? Absolutely. We found it. The moment we solved for NiCl, we found that shape is tetrahedral. There are 2 unpaired electrons. Unpaired electrons will go for will show paramagnetism, and everything is paired, then it will be diamagnetic, correct, everybody? Absolutely right. The moment we solved for NiCl4, we found that this is the only one that is coordinating with the answer. So this is the correct answer. However, if you want it, you can solve it a little more. Here is the explanation. You can solve it for NiCO4. You can solve it for NiCN also, and you will be able to find that still this is the correct answer. Got it clear, everybody? Amazing. Oh, I can see so many students are watching it live. Thank you so much. Thank you so much. You can call up more friends. And hey, if you like the session, don't forget to hit the like button also. That will be really helpful for me, okay? Moving on, the complex that has the highest crystal field splitting energy. Once again, everybody, highest crystal field splitting energy. If this kind of questions comes in your exam, what are you going to do? Check out which one is a strong field ligand. Which one is a strong field ligand, everybody? Yes, is Cl is a strong field ligand? No. H2O, NH3? No. NH3Cl? No. Cn. Cn is a very strong ligand. So that means option C. If it is a strong field ligand, then strong field ligand will definitely cause more splitting, isn't it? Yes, definitely cause more splitting. See, imagine this, okay? There is a family of 4. I gave you the same example. There is a family of 4, mother, father and 2 siblings, 2 brother and sister, let's say, okay? Now, usually what happens, let's say the brother is younger. I mean, this is what is my case, right? This is what is my case. I'm the elder daughter. My brother is younger than me, right? My brother is younger than me. Now, what happens is, everybody, let's say some guest is coming. So, mom and dad, they have the master bedroom. I have a room for myself. My brother has a room for himself, right? So, when guests come over, what he has to do? My brother has to give away his room. Now, let's say that there is one relative who is coming, who has a very strong personality and we don't like him. Then what will happen? The splitting or the excitement will be a little more, right? The amount of, the fact that we don't want to give the room away will be a little more in our case, because we don't like that relative. The same thing happens. See, if this is a strong ligand here, it will cause more splitting in the family. It will cause more splitting in the family. That's how you can take it. This is the closest analogy that you can get. Okay? How to calculate splitting energy? Mohan Rao, sweetheart, darling, what are you doing? What are you doing? This is the last leg of it. You have forgotten everything, huh? You've forgotten everything. You don't really have to calculate the splitting energy. It's fine. You just know that in octahedral the splitting is a little more, in tetrahedral it is a little less, and if it is a strong field ligand, then the splitting will be a little more. But anyway, we will see this thing. Okay? Where is Shimon sir? Everybody, for one last time I am telling you that yes, Shimon sir is still in Vedantu. I do not know why is he not taking classes. Maybe he is occupied more with V Master, and that is why he is probably not able to give time to this channel right now. But don't worry, he is still here. Like I said, I am going to ask him that why is he not able to take classes. But don't worry about it, he will definitely tell you. Okay, he will definitely tell you. Now, can you please focus on my session? Please focus on my session. Yes, you can. We are kind of, by the way, Siddharth, I have already recorded the mind map. Please watch this also. Huh? Please watch that also. Okay? Watch that session so that you understand everything. This is a problem solving session, but I have recorded the mind map where you can, in short, in half an hour, you will be able to understand pretty much everything. So please watch that. Chalo, moving on. The denticity of an organic ligand biuret is denticity. Denticity is it? Monodentate, bidentate, tridentate, tetradentate. What is it? The correct answer is of course 2. Correct answer is 2. Biuret is a bidentate ligand. Okay? Biuret has a 2. I mean, it can hold a ligand 2 ways. Okay? It can hold the ligand 2 ways. Okay? Alright, see. NH, C. It forms complexes like this. See? Cu2 plus NH. So, biuret has 2 denticity. Okay? Next chapter will be metallurgy or S block and hydrogen. S block and hydrogen, I am going to take it together. Okay? Alright. Don't hurt fans. When? When did I hurt yours? When did I hurt you all? Next question. The number of geometrical isomers found in the metal complexes. Okay, very easy. Let's do this. PtCl2NH3 2. Let's do it. PtCl2. Cl2 can be Cl here like this. NH3 can be here like this. Or it can be PtCl, right? NH3 NH3, it can be like this. So this one has 2, okay, this one has 2. Now NiCO4, it is homoleptic. It is homoleptic, that means this one will be 0. Yes, this one will be 2. So 2, 0, option C again. 2, 0, option 2 again, option B again, okay? Option B again, option C again. 2, 0, 2, 2, this will be the answer. You can try for all of these also, you can try it later. But here is the solution, okay? Here is the whole solution, you can check it out. So I'm trying to solve the questions faster so that you also get a clear idea about it, okay? Chalo, moving on. Oh, this is very easy, I think. This is very easy. Let's find it. Let's find it out. Chalo, let's do this. Okay. This is what kind of isomer is this? We all know, right? This is definitely a coordination isomer. Coordination isomerism. CONH3 NO2 3. CONH3 NO2 3. Okay. This is optical isomer. This is solvate isomer. That means definitely this is linkage isomerism. Yes. What is a linkage isomerism? In a linkage isomerism, if you have NO2, SCN, know that they can hold on to the ligand with the nitrogen hand. They can also hold on to the ligand with the oxygen hand. If it is SCN, they can hold on to the ligand with the S hand. They can also hold on to the ligand with N hand, right? So that means which one is it? A is 3 and B is 1 and C is 2. D is 4. Option B. Option B is the correct answer. Am I right, everybody? Option B is the correct answer. Yes, option B is the correct answer. Shabir, what are you doing? Yes. Bye bye. Okay. Good night. Not to you guys. You are not leaving. I said bye bye to someone else. No. Don't go. Don't go. Chalo. Okay, moving on. Yes, moving on. Next question, everybody. Next question. Let's do this. Yes. No. You guys, I'm not saying bye to you. No, I'm not saying bye to you. Come back. Chalo, next question. The total number of isomers for a square planar complex is... Okay, let's do this. This is also easy. See, the metal is supposed to be here. Okay, if the metal is here, then let's do F is here, Cl is here. Now, SCN, right? SCN. It can be SCN, it can be NO2 also, right? 1 second, let's not do that. This will not be proper. This will not be proper. 1 second. Yeah, we can write SCN here and we can write NO2 here. Correct? Yes. Now, the total number of isomers for a square planar like this, how much, what can you do? It is M, A, B, C, D type. Yes, M, A, B, C, D. Very good. That means how many isomers are possible? Absolutely right, Krishna. The correct answer is 12. The correct answer is 12. Absolutely right. Yes, we have studied this. We have studied this when we read about coordination compounds, isn't it? But anyhow, this is the diagram here. If you are still not able to understand, then this is the diagram here. You can see. See, it can be F, Cl, SCN. But here, right at this position, you can have NO2, you can have SCN, you can have Cl. 3 are possible. Right here, once again, F, Cl, NCS. Here, NCS, not SCN, NCS. Right now, it is holding the hand with nitrogen. But here again, it can be NO2, NCS, Cl. 3 possible. Same like this for here and here also. So you find that 12 is possible. Okay. Chintu bhai Risker, I would rather right now you focus on the session, please. If you cannot, I stay in Bangalore. After your results, you can come to Vedantu office and then we can talk about it. Okay. Now can you please focus? Let all the students study. No, please. Okay. Chalo. Now let's do this. Yeah. Match the column. Okay. Cobalt is present in vitamin B12. Do we know this? We know this. Yes. Magnesium is present in chlorophyll. We know this. Yes. Zinc is present in carbonic anhydrase, isn't it? And RH is a Wilkinson catalyst. That means that cobalt, vitamin B12, A3 and D2. That means option C. Option C. Mg is in chlorophyll. See, with just if you know 2 answers also, you can answer it. So easy. So easy. And this has come in JEE Main 2019. Easy, right? You can do it. Is the confidence getting boosted up now? Huh? Does it feel like, yay, we can do it, we can do it? You can do it, my dear student. You can do it. You guys are really amazing. And like I said, I will keep your place in the Vedantu's valedictory function. All you have to do is crack the exam and meet us here, okay? Alright. Karthik, actually Saturday 5 p.m. a session is coming. You can score 95 plus, and I have told you about all the short topics. Please watch that. You will get to know about it, okay? Next question. The coordinate number of TH in K4 C2O4 4 OH2 2. C2O4 is oxalato. Oxalato is bidentate. Oxalato is bidentate. That means 2 into 4 how much? 2 into 4 is equal to 8. OH is 2. 8 plus 2, 10. Correct? That means answer is option B. Can you believe it? These kind of questions have come in JEE. And we think that, oh my god, what JEE is going to be, right? It's going to be very tough. You can do it. Does it make sense? You can definitely do it. Don't worry about it at all. You can do it. Chalo, next question. Next question, everybody. See? C2O4, oxalato is bidentate, OH is monodentate. That's all we need to do. Got it? The number of bridging CO ligand and CO-CO bond in CO2, CO8. Let's find it out. CO2, right? So CO2, here we have, and then we have 8. If it is 8, then we will have 1, 2, 3, 4, 5, 6, 7 and 8. Am I right? This is going to be the structure. This is going to be the structure. If this is the structure, that means CO ligand and CO-CO bond. How many are there? How many are there? Huh? CO-CO bond is 1. There is one CO-CO bond. One CO-CO bond, right? 1 here. And CO ligand is here. 1 and 2. So 2 and 1, option C. Option C, 2 and 1. Yes? 2 and 1, option C. Right? You can, Shabib, you can. Don't worry about it. Yes, Mangala is actually absolutely right. Just focus on the short topics right now. Focus on the high weightage topics. You can. Don't worry about it. Okay? Alright. So this is what we have. This is what we have. Moving on. Moving on. Oh, this is the structure that we made. See, we are all correct. Very good. The following ligand. You know what? The structure might look very difficult for you, but can I tell you, it is very easy. It is very easy. See, let me tell you. Let me tell you. For any ligand, where is it going to hold the hands from? Oxygen, nitrogen, 2 nitrogen, 2 oxygen. What is it going to be? Tetradentate, right? What is it going to be? Tetradentate. That's it. That's it. So easy. No, not tridentate. Shiva Gaming, which one did you not understand? Which one did you not understand? The previous question, this one. This one. CO, carbonyl ligand. The structure here is mentioned CO2, CO8. Okay? CO2, CO8. How can we draw the structure? Let's find out. CO2. So let's do CO, CO. 2 over. Okay? 2 over. We have to draw 8 more now. So can we draw like this? 1, 2, 3, 4, 5, 6, 7. 1 second. 7, 8. Correct? This is the structure, right? Now it is asking you the number of bridging CO ligand. Bridging CO ligand. See, this is the one that is forming a bridge. This is the one that is forming a bridge, right? Remember that B2H6 dimer, bridge, banana bond, kind of like that. So there are 2 bridging ligands here Yes, two bridging ligands. CO-CO bond. CO-CO, see, CO-CO. Yes, CO-CO bond. This is the only CO-CO bond here. So one, that's it. Got it? Understood? That's it. That's it. Rest everywhere, see, rest everywhere it is connected to C, 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 O, okay, C, C, like this. It's different. Only here it is CO, CO bond. Okay, got it? That is one. This one everybody has understood. This one everybody has understood, yes. It's very easy. It is tetradentate, okay, tetradentate. Next. The correct order of the spin-only magnetic moment of metal ion in the following low spin. VCN6 4 minus. Once again everybody, very easy. What you have to do is, thank you so much. Okay, no problem. Now see, Karthik, that you have to ask Shreyas sir, okay, that you have to ask Shreyas sir. Okay, this is also very easy. What you have to do is find the oxidation state of all of them. Find the oxidation state of all of them and find the spin momentum. Find the spin momentum. You want me to show you? You want me to show you all of these? Do you want me to explain all of these? I had also told you central metal. Obviously, central atom is different. So that is why you have to find the oxidation state for everyone. No, you will have to find the oxidation state for everyone. Okay, chalo, let's find it out. Chalo, let's do it. Huh? Vanadium. What is the electronic configuration of vanadium, or what is the atomic number? Scandium, titanium, vanadium. That means 23. Scandium is 21, titanium is 22, so vanadium is 23, right? So 23, that means 4s2 3d3, clear? 4s2 3d3, that is going to be the electronic configuration, yes? Now it is VCN6 4 minus, right? So if I have to find the oxidation state, let's find the oxidation state. X, Cn, Cn has what? Cn has -1 charge, so -6, yes? And 4 minus, so let me write here 4. So X is equal to 2 plus 2 oxidation state, plus 2 oxidation state, right everybody? If I have plus 2 oxidation state, that means vanadium 2 plus is equal to 3d3, yes, 3d3. Now because this is a 3 and d3 configuration, even though Cn is a very strong ligand, I gave you the exceptions also in the previous session of mind map. I gave you the exceptions also. In the exception I told you that if it is D1, D3 configuration, then there is no question of getting paired. If there is no pairing happening, then that means that there are 3 number of unpaired electron. If it is 3 unpaired electron, what is the magnetic moment? Magnetic moment will be, root over 15, that means 3.9. This has 3.9, correct? Agreed everybody? Making sense? Making sense? This is paramagnetic, absolutely right. Root over 15, sweetheart, 15, not 18. Okay? Moving on. FeCN6. Chalo. FeCN6 4 minus. Let's do it. What is it? Scandium, titanium, vanadium, manganese, chromium, iron. No. Scandium, titanium, vanadium. Same. 26. Yes, it is 26. So 26, that means it is going to be 3d6 4s2. Am I right? 3d6 4s2. Am I right everybody? Ma'am, can pair with EG, so why is it? Can't understand your question. What are you asking, Bacha? Can't really understand your question. What are you asking? 4s2, 3d6. Now here x, again same thing, -6 is equal to 4, 4 minus, so x is equal to 2 plus 2, right? X is equal to plus 2. Let me erase this. If it is plus 2, that means Fe 2 plus is equal to 3d6. If it is 3d6, then this is how we are going to draw it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? But Cn is a strong ligand. Cn is a strong ligand. That means 1, 2, 3, 4, 5, 6. It will get paired up. It will get paired up. Will it have any magnetic moment? Will it have any magnetic moment? 0. Right? This will have 0. This will have 0. Now that means Fe2 plus is less everywhere. This ruthenium. Ruthenium, for that also if you find out, ruthenium will have how much? Ruthenium is a 4D series, bacha. For 4D series, every ligand acts as a strong field ligand. Ruthenium is a 4D series. Every ligand will act like a strong ligand. That means everything will get paired up. But even after it gets paired up, what will happen? Even after it gets paired up, there will still be, when was your next class? I don't know. For ruthenium, find it out. For ruthenium, find it out. Chalo, let's find it out. For ruthenium. Ru NH3 6 3 plus. ठीक है? Alright. So X will be equal to 3. X will be equal to 3. Since this is a neutral ligand, so X is equal to plus 3. Right, everyone? Now what will happen is, after that what will happen? Ru plus 3. Ru plus 3 is equal to 45. 45. Yes. Now 45, if I draw it like this, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. See, what did I tell you? For 4D, everything is a strong field ligand. Pairing will happen. One is still unpaired. Yes, if I calculate for this, then 1 plus 2. Root over, what will I get? 1 plus 2, 3. So root over 3 is equal to how much? Root over 3 will be equal to 1.9 something. 1.9 something. Right? So what do I get? And then finally you have to calculate for CR also. Calculate for CR, how much will you get? For CR it will be, I think, around 2.9. For CR it will be 2.9. That means that vanadium will be the highest. Then comes CR. Then comes ruthenium and then comes iron. So option A. Simple question, but I tried to explain it to you so that you know how to solve it. Okay, so that you know how to solve it. Clear? ठीक है? Everybody understood this? Everybody understood this? Sandipta, I had given you the whole list, no? I had given you the whole list, no? Please find it out. CN is one of the strongest, okay? CN is one of the strongest ligand. Chalo, moving on. Okay. Complete removal of both the axial ligands along the z-axis from an octahedral complex leads to which of the following splitting patterns? Relative orbital energies not on scale. Do you guys understand this question? Do you guys understand this question? How many of you do understand this question? Chalo, let's find it out. How many of you understand this question? Tell me, how many of you do understand this question? You will, Shabib, you will. Karthik, you understood, and I can see that you have answered also. Very good. Do you remember that in case of octahedral, which ones are the axial ligands? Which ones are the axial ligands? Yes, the axial ones were d x square, y square and dz square. Isn't it? These ones were axial. Yes, these ones were axial. Correct? Shiva Gaming, do you remember the concepts of coordination compound? The concepts of coordination compound, do you remember the splitting in octahedral? Do you remember the splitting in octahedral? Yes. Do you remember them or no? No. Okay. Chalo, no problem. Purvi, in that case, can you watch the previous session that happened on Saturday? On Saturday? No, not Saturday. I think on Wednesday. Yes, the theory of it. I had taken a class on the mind map of coordination compound. In half an hour, I have tried to explain everything. Please watch it, sweetheart. Please watch it. It will be really helpful. If you do not remember, then this is what is going to help you. Okay? Please watch it. So these are the axial ones. And which one is the non-axial ones? The non-axial ones are the rest of them. Okay? So dxy, dyz and dzx. These are the axial ones. Now, it's saying that it is octahedral complex, right? If it is octahedral complex, that means it is going to be somewhat like this. M will be here. It will be, let's say that this is Z, this is X and this is Y. So what are they saying? They are saying that along the Z axis, of both the axial ligands have happened. Removal of both the axial ligands, you have removed it completely. If you have removed along the z-axis, that means that the shape is going to be somewhat square planar now. It is going to be square planar. It will be x and y. This will be x, this will be y. Right? Now, as per the splitting of octahedral, we know that usually these ones have higher energy. These ones, the axial ones have higher energy because it comes directly on the axial head. Yes. And these ones are the non-axial ones. They have a lower energy. Right? Right, everybody? But what did we say? We said that can't understand. Purvi, you have to watch the theory, bacha. Have to watch the theory. Chalo, let me try to explain it to you again. Okay. Alright. From the very basic, everybody. D orbitals have, there are 5, orbitals in D. Am I right? Everybody? Purvi, do you know this much? Do you know that usually whenever we make d orbitals, we make it like this, right? 1, 2, 3, 4, 5. Correct? Yes? Now in this, what happens is, now, and it is saying that it is octahedral geometry. If it is octahedral, that means a central metal atom from 6 sides, the ligands will try to approach it, right? From 6 sides, but Karthik, I have to make sure that everybody understands, no? Everybody has to understand, right, sweetheart? Please don't do that. I understand that you are done with it. Just give me 2 minutes. I'll try to explain it and finish it, okay? Yes? So, it can, from 6 sides, there will be ligands approaching. 6 sides, that means X, X, Y, Y, Z, Z, right? Yes? Now, the question says that complete removal of both the axial ligands along the z-axis. Along the z-axis, both the axial ligands have been removed. Correct? Yes. Yes, we understand that. That means that now it is going to be a square planar. We will have only X, X, Y, Y. Am I right? Right, Purvi? That is correct. That means, yes, that means now that what will happen? Now the ligands are trying to approach from X and Y. The ligands will try to approach from X and Y. If it is approaching from X and Y, that means that this ligand will have really high energy. Yes, dx square, y square, this will even go up. Correct? Absolutely right. Yes. Right? Absolutely right. Then after that, dxy, because x and y axis, right? X and y axis, so dx square, y square, dxy will be the second one. However, dz square is still there. Z square is still there. So that has moved down. It has definitely moved down. So that means that dz square will be the next one. And finally, we will have this. So option A is the correct one. Now did you understand, Purvi? Now did I make it clear? I hope I made it clear. If not, the same question explanation is there on Vedantu's website. Just copy this and paste it. You will find a whole explanation there. Just watch it. Just read it and write it down in your copy. You will understand. Same thing is explained there also. Okay? Chalo, no problem. No problem. Option A we have understood. Now, octahedral complexes of copper undergo structural distortion. Structural distortion was told by Jahn-Teller, right? Or Jahn-Teller. Which one of the given copper complexes will show the maximum structural distortion? Maximum structural distortion. Tell me. Any idea? Sure. Raghav, we will. Don't worry. Thank you, Tejaswini. Thank you so much. Acha, batao, everybody. Very easy this is. Shall I just tell you? See, CuH2O6. CuH2O6. Okay? That means that it will be T2G6. Right? T2G6. Am I right? No. Why is the C? No. Sorry. This is not the correct answer. Ethylene diamine, En ethylene diamine, H2 and CH2 NH2. ठीक है. Octahedral complexes of copper to undergo structural distortion. Which one of the given copper complexes will show the maximum structural distortion? Okay. Now you tell me. Now I have read the question. Now you saw the answer. No. Now you saw the answer. Yes. Now what is the explanation? Tell me this. What is the explanation? Why is it this? Why is it this? Anybody? Anybody? Shabibia, don't do all of this. Don't do all of this. Tell me. Anybody knows the explanation? Karthik, where are you? Karthik, where are you? Karthik, I need you to answer this. Tell me. I need you to answer this. Come on. Then we'll move to the next question. Chalo, you answer this. You tell me the answer. Next. FeCN6 3- should be an inner orbital complex ignoring the pairing energy. The value of crystal field stabilization energy for this complex is what? You didn't remember the Jahn-Teller. Chalo, no problem. I'll tell you later. No problem. Come back to it. Come back to it. Let me tell me this. Tell me this answer. No, you don't have to remember the Jahn-Teller. Do you remember the structural distortion? That will also give you the answer. If you know the structural distortion, that will also give you the answer. Chalo, think about it. No problem. Think about it. You have some amount of time. No problem. Think about it. Then tell me the answer. Moving on. The answer is going to be 2. Why? Because see, Fe3, it is written as inner orbital complex. If it is inner orbital complex, it will be what? D5 with pairing. So configuration is T2G5. Now crystal field splitting energy will be 5 into -2/5 delta octahedral. Yes, this is the formula. This is the formula. Now if you ask me how does this come, then you will actually have to go back to the original video of coordination compound and watch it. Please watch it if you do not know how this formula is coming. And finally you have -2 octahedral. Okay, this is the correct answer. This is the correct answer. Moving on, next question. Do we know this? NiCO4, NiCO4, NiCN4 2-, COCN6 3-, COF6 3-. Come on. What do we know? What do we know, everybody? Do we know this answer? We know this answer. We know the geometry and everything. Don't we know? C. It is B. It is B. Why? C. NiCO4 is sp3 hybridized. We know that. NiCN4, this is dsp2 hybridized. Okay, this is dsp2 hybridized. Alright, Cn is a strong field ligand. Cn is a strong field ligand, it will cause pairing. Cn is a strong field ligand, it will cause pairing. So dsp2. Okay, again COCN6. See, this will also cause pairing. This will also cause pairing. Yes, but there are 6. So sp3 d2. Alright, no, d2 sp3. What am I saying? So sorry. Once again, NiCO4. Let's do this. NiCO4. This one we have done it. sp3 we know it. Okay. NiCN4 2-, this is dsp2. COCN6 3-, this will be d2 sp3, and COF6 3-, this will be sp3 d2. This is the correct answer. Okay. Where can we get full lecture? It's there in this channel only. I have taught. It's there in this channel. Just search for coordination compound by Nabamita Mam. You'll find it. It's there in this channel only. Okay. Moving on. Total number of relatively more stable isomer possible for octahedral complex. Oh wow. What an easy question. What an easy question. Can you tell me this? Ayush, look at the channel name, bacha. The channel name is only Vedantu JEE English. How can I teach you in Hindi here? Huh? For that you have to go to NEET Made Easy. NEET Made Easy, there Vasim sir is teaching you in Hindi. 2. No. It's not 2. It's 3. It's 3. How? You wanna see? You wanna see? See, EN, 2 EN, right? EN. Then you will have SCN, right? Then you will have, see, then you will have NCS, SCN. 3 are possible. 3 isomers are possible. Okay, 3 isomers. No, not 2. 3 isomers are possible, bacha. 3. You're forgetting it. Now, the total number of Mn double bond O bonds in Mn2O7 is. This is very easy. Very easy. Mn2O7 permanganate, no? Only one is a singular bond. So, option 6. This is the bond. 1, 2, 3, 4, 5, 6. This is the permanganate here, right? So 6 bonds. Okay, 6 is available. Without lifting your pen, you can answer this. And very good, absolutely right. AA2, B2. Yes. How to find isomers in shortcut? Shiva Gaming, there was a chart, if you remember. MAA2, B2, MABCD. How many isomers will be formed? Then there was MAA. B, C, D, like that. There was a chart that I had given it to you in the first session of coordination compound. Go through that. Go through that. You will find it, okay? MA3, B3, yes, I have forgotten all of them, but yes, there was a chart. So if you just look at the chart, you will be able to find it, okay? Alright, chalo, moving on. The metal complex that is diamagnetic is atomic number Fe2, Fe26, Cu29. Okay, this one also we know, na baba? This one also we very well know, right? Yes. For coordination compounds for NCERT, no. I would suggest watch the videos in 1.5x or 1.2x right now from any of the teachers that you like, and you will be able to solve it. You don't have to read through NCERT. In NCERT, the valence bond theory and crystal field theory actually are a little confusing. So I would rather suggest that please watch some video. Video will help you more. We can do this, right? This we can easily do. The atomic numbers are also given, bacha. The atomic number are also given. That means that it is becoming even more easier. So you have to find the atomic number, find the oxidation state, then look at what are the ligands. The ligand is all of them. CN, strong field ligand. Cl is the only weak field ligand. CN. It will definitely cause what? Pairing. Yes, and all of them are 3D. Copper, iron. All of them are 3D series. So you know that these two are strong field ligand. These three are strong field ligand with 3D series. This is a weak field ligand. No pairing. You can find it out. Right? Option A was the correct answer. Why? Because copper is D10 configuration and no unpaired electrons. That's it. Shabir, I'm telling you once again, bacha, in this channel only you will find coordination compound lectures. 2 sessions I have taken. Max to max, both the sessions together will be of 3 hours. Watch both the session in 1.25x or 1.5x. I promise you, you will be able to understand. If you still don't understand, no problem. What you can do is, come back to this session and just write down your doubt in the comment section. I personally watch all the comments. I will definitely solve it for you right then and there in the comment section. Is that okay? I will help you, don't worry. P block. Yes, Kirti, P block is also explained. I have taken P block almost thrice. 2 sessions I have taken previously. I took the mind map also. I have taken the P block previous year questions also. Please watch them. Okay? Moving on. The correct order of energy of absorption for the following metal complexes is. Correct order of energy of absorption for the following metal complexes is. Again, this is also going to be easy. Yes, can you all do this? The same way you have to do it. Okay? Same way. Just find it out. Energy of absorption. You will figure it out. Okay? All of these, see, H2O, NH3, En. All of them you can see. In all of them you have nickel. 3D series. Same central metal atom. Yes. Yes, coordination compound is very important. It is one of the majorly scoring chapter. Okay? H2O is neutral, NH3 is neutral, En3 is neutral. Then you find it out, the correct answer. See you, no ma'am, it is completely, yes, no. Oh, actually option, no, it is this. Oxidation state will also matter, no? See, K3, K2, that also you have to see, no? It is option A only, okay? It is option A only. Yes. Now, the conductivity of a solution of a complex with formula COCl3NH34 corresponds to 1:1 electrolyte, then the primary valency of central metal ion is, Mohan, you had asked me, no, what is primary valency? See, you have a question related to primary valency. The answer is 3 here. How? See, in 1:1 type of electrolyte, the ions, they have +1 and -1 charge on them, right? If it is 1:1 type of electrolyte, the ions will have a +1 and they will have a -1 charge on them. Now, the possible compound is CONH34Cl2 plus Cl minus, right? So, the oxidation state of central metal atom represents the total number of primary valence. Of course, primary valency is always oxidation state. That's how you find it out. So, primary valency will be 3. Easy? 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 So, the only thing that you are not doing is probably not understanding the question. Read the question twice, understand the question, solve it. Maximum questions, do you see maximum questions are related to oxidation state and splitting energy? So, please, if now you have understood, even in coordination compound, there are 3 things that you have to bother. Crystal field splitting energy, questions will come. No doubt about it, questions will come. Oxidation state, no doubt it will come. And the third one is maybe nomenclature will come. Maybe. Nomenclature is again not that important, but these two are very, very, very important. You drop this, you're not going to get marks in coordination compound. Don't forget to do this. Okay? Number of complexes which will exhibit synergic bond amongst. Again, you know the answer. Tell me. Splitting energy. Kirti. Acha, chalo, I'll explain it to you. Later on, I'll explain it to you. Okay? Don't worry. I'll explain it to you. Don't worry. I'll explain to you. Yes. The correct answer is 3. How? CO ligand shows synergic bond. So, all complexes can show synergic bonding. Okay? See? All of them has CO, CO, CO. It will show synergic. It will show synergic bonding. Okay? So, answer is 3. Very good. Next, in the cobalt carbonyl complex, CO2, CO8. Oh my god, I think that question was wrong or what? Was it CO, capital O, or was it CO only? Did we do that? Was it capital CO, CO or C? Cobalt, cobalt. I think it was cobalt only. I must have written cobalt only. Can't make that mistake also. Anyway. So, CO, CO bond is X and terminal CO ligand is Y. So, X plus Y. We made the structure, no? We made the structure, right? 7 is the answer. A. 7 is the answer. See? Number of CO-CO bond, that is cobalt-cobalt bond, is 1. Number of cobalt-cobalt bond is 1. And the number of terminal ligands it has said. It has said terminal ligands. See? Terminal CO ligands. So, 1, 2, 3. 4, 5, 6. This is the bridging ligand, no? This is the bridging ligand. These two are bridging ligand. These two are terminal ligands. Okay? So, it will be 1 plus 6, 7. Okay? It will be 1 plus 6, 7. Got it? Clear? Very good, Karthik. No problem. Chalo, moving on. Next question. The oxidation state of iron atoms in compounds A, B and C respectively are X, Y and Z. The sum of... What did I just tell you? You have to find the oxidation state always. You have to find the oxidation state. Find the oxidation state, add them. That's the only way to solve this answer. That's the only way to solve this answer, right? So, find the oxidation state, FeBx. Find the oxidation state here. Oxidation is +2. Next, oxidation is +4. Next, oxidation is 0. So, 2 plus 4 plus 0 is equal to 6. The answer is 6. Okay? Answer is 6. Very easy. Mostly it is about oxidation state, bacha. Mostly it is about oxidation state. So, please take a look at that. The number of possible optical isomers for the complexes Ma2B2 with sp3 and dsp2 hybridized metal atom respectively is A and B are unidentate and neutral, and unidentate and monoanionic ligands. A and B are unidentate neutral, okay? Unidentate neutral, that means no charge, but one single, it's monodentate, okay? And this one is unidentate, but it has anionic, that means -1 charge is there. -1 charge is there. So now you tell me that number of possible optical isomers. How many number of possible optical isomers are there? 0 and 0. 0 and 0. Why? Because it is Ma2B2, no? Ma2B2. Ma2B2, optical isomer. Very easy. What are optical isomers? Optical isomers are those isomers which look very similar but they are not overlapping. Easiest example is your hand. Your hands look exactly similar, but if you try to overlap them, what will happen? It will not be able to overlap. It will not be able to overlap. Okay? Alright? So that's the answer. Okay? That's the answer. Got it? Take a look at it. See? Ma2B2, tetrahedral, square planar. This has a planar symmetry. This is, look at this. So total number of isomer is 0 in both the cases. Has a plane of symmetry, no? It has a plane of symmetry, right? AA, BB. See? AA, BB. Optical isomer will be 0. That's it. Very easy. Correct. Next. Arrange the following metal complex compound in the increasing order of spin only. Same question. Questions are repetitive. See? Questions are repetitive. Isn't it? Same thing again you have to do. Find the magnetic moment. Find the magnetic moment. Find the magnetic moment. Find the oxidation state. Find the oxidation state. That's all. Oxidation state, crystal field splitting energy, magnetic moment. That's it. These are only 3 topics you do from this chapter. You are done. Sorted for your life. Okay. You are sorted for your life. Okay. Next question. Next question. Oh, that's it. We are done with the chapter. That's it. We are done with the chapter. So I'll be giving you the notes also. You can go through the notes. You can go through these questions. If you want, you can solve them again. Write down the question and then try to practice them again. And I think that you are sorted, right? Coordination compound seems to be very easy right now, isn't it? Acha. Now coming back to who asked me, ma'am, can you please explain splitting? Splitting. Who was the one who asked me to explain splitting? Who was it? Chalo, let's try to understand, okay? Once again, I am going to next what lesson? Next lesson will be metallurgy and S block and hydrogen. And then on 23rd, we will do a mega problem solving on S block, hydrogen and metallurgy. Okay? Alright, we will do all of these. We will do all of these together. Jahn-Teller is nothing actually, Karthik. It's just the structural distortion, okay? It's just the structural distortion, nothing else. Nothing else. Just the structural distortion, that's it. Is it possible to crack mains? Of course not, Shubhas. Although inorganic will fetch you most amount of the marks. Inorganic has around 35% of weightage. So if you do inorganic and if you do organic, just organic and inorganic will also be able to fetch you 60% of chemistry class. Okay? Saket will have to ask Shimon sir. I will ask Shimon sir and let you know. Okay? 24th is your JEE exam. Yes. So 23rd we will do. See, metallurgy, S block and hydrogen, all of them are very small sessions. Okay? All of them are very small sessions. So if you have done the other things, it's okay. It's okay. Explain splitting energy. Chalo, let's understand this. I'll give you the same analogy, everybody. Okay? Same energy. So imagine that there is a family of 4 but living in a 3. Yes, Damik, I will not forget. I'll transfer it right now and send it, okay? Listen, 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 listen. 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 There is a family of 4. Mom, dad, brother, sister. They live in a 3 BHK house, okay? So, mom and dad has a master bedroom. Brother and the sister, they have one single room for each other, okay? Now, let's say that one, a relative is coming. A relative is coming. Okay? A relative is coming. Now, if the relative is coming, then what will happen? That if the relative coming, now they stay in a 3 BHK house, they don't have a guest house. So, if the relative comes, then what will happen? The relative would want to take one of the room from them, no? The relative will definitely want to take away one room from them. Yes? Either the younger brother, usually it is the younger one who has to give away his room, right? Give away his or her room. So, the moment the relative is coming and the younger brother knows that someone is coming, right? It feels like, oh God, why? My life is gone. What can I do? Like it starts to become all nervous and anxious, and that is why the energy suddenly rises up. And that is why the energy suddenly rises up. So, in case of tetrahedral, yes, or the brother is going to be kicked out and put into the sister's room. So, what will happen? The brother is going to be very excited, very anxious, and what will happen? It will start to fight with the sister also. You don't have have to give away your room, but I have to give away my room. It will go and fight with the mother and sister. Why are you not giving your room? Why do I only have to? So what is happening? This family split up. The family split up just because of this, right? Just because of this family split up. The energy is got split up. That is exactly what happens in a tetrahedral or in an octahedral approach of ligands as well. Okay. So d orbitals, there are five orbitals in D. Sometimes what happens, the ligands, they want to approach and they say that give us the room, give us the room, give us the room. Now either the d orbitals, if the ligand is very strong, what is it going to do? It is going to ask them to pair up. Just like how the brother was thrown away from his room and put into the sister's room, the same way the ligand, if it is very strong, it is going to ask the orbitals to pair up. Like, hey, you pair up, I need the orbitals empty. It will empty up the orbitals and then it will fit itself into those rooms. Then what will happen? Your hybridization is going to be D2sp3, dsp3, D. There is an inner d orbital that is there, which has emptied the orbital and it has given it to the ligand. Understood, everybody? Yes? Now did you understand? So this splitting, when it happens, what is the splitting? That means how much did the brother fight with the parents and fight with the sister? That's it. That's it. Sometimes what happens is, in case of octahedral, the axial ones, they are the ones who are going to take the hit on their head. It is going to be dx square, y square, dz square. These are the axial ones in octahedral who are going to take the hit. In case of tetrahedral, what happens? It is the dxy, dyz and dzx. They take it on their head. So they go up, and dx square, y square and dz square, they stay at the bottom. So this is what happens. Now please go back to the coordination compound mind map. Just look at the diagrams and listen to the lecture in 1.5x. Do not waste your time. Watch it in 1.5x. I promise you, you will understand. If you still don't understand, come back to this video, ask me the doubts, I will explain it for you. Alright, with this note, Tara bye-bye, and can you explain how to find which complex has highest CO bond? What's CO bond? Not able to understand you, this thing. Geometric isomers. Geometric isomers also you know how? Shall I tell you? See, PT, Cl, NH3, NH3. What is this? Cl is on the one side, cis, okay? Or it can be PT, Cl, NH3, this is trans. So in geometric isomer you have cis trans and you have fac mer. Just study that. You'll be able to understand. That's all for today, everybody. Don't forget to like, share and subscribe to this channel. This channel deals with all the information about JEE in English. Tara bye-bye. Good night, everyone, and see you all.